Hey, genius. I'm just here to do a short video about imaginary numbers. So we know about numbers, and we can think of the number line where we have the negative numbers, we have zero, we have the positive numbers, and so on. And there's numbers in between. There's fractions. There's 1.2746, whatever, right? Here's negative one, here's negative two, and so on and so forth, right? But what if numbers had two components and they were two-dimensional? So numbers were sort of like vectors in a way. Not in a way, they were vectors. So, for example, let's say that this is the y-axis and this is 1. So this is 0 on this number line and 1 on this number line. So this point right here, let's make it red, dark red apparently. This point would be 0, negative 1, and we would be able to write it as 0 plus negative 1 times I. Okay. And what do we know about this I? So supposedly I is the square root of negative 1. If that's the case, I squared is when you take the square root of negative 1 and multiply by itself. So you should have negative 1. And so I squared would be negative 1 plus 0i. There's no I component. So therefore, I squared would be right here. Interesting. Interesting. What about I to the third? Oops, there's no square here. I squared, right? What about I to the third? Well, that would be I squared times I. I squared times I. That's negative 1 times I. Hmm, okay. So there's no real part of that number. So therefore, the real part is 0. So it's 0 plus negative 1i. So that would be right here. Why did I make this negative 1? I don't know. This is just supposed to be a 1. Yeah. So this number here was 0 plus 1i. But this number here, this is in fact 0, negative 1. So it's 0 plus negative 1i. Okay. So are we actually going around this circle? That's an interesting question. What is I to the fourth? I to the fourth is I squared times I squared. That would be negative 1 times negative 1. That would be 1. So that would be 1 plus 0i. There's no I there. And therefore, I to the fourth is just 1. And then the cycle starts all over again. That's interesting.